been responding or preparing for an epidemic such as this and put the country in good stead to handle it. If we talk about we are considered to be a high risk, that we were a very vulnerable, the whole of Africa, very vulnerable to the COVID-19. And the expectations and predictions was that there will be over 190 deaths in Africa and that you will be finding bodies on the street. But they did not reckon with the resilience and the preparations that we had in Africa. The years of epidemics had given us some form of expertise, even though we may not always deploy them optimally, and even if we don't always have the funds. But when we have scientists together doing what we do in GET, then it tells us where we are going as a continent. There's a lot to learn from the continent of Africa concerning the response to this pandemic. Africa responded proactively. Africa responded cohesively with the organization by the African Union and the keying in of all the governments, and also the working together of scientists, not just here in Lagos State, but across the continent. So I want to congratulate all those who have been involved in the deployment of the brains in Africa, for those who have been in the front line, working to ensure that COVID and diseases such as this would be something that we can cope with. I also want to congratulate Lagos State in particular, that's the epicenter of the COVID-19 in Nigeria, for the stellar work they have done. At all times, the response has been as a result of and in response to the science. There were strategies that were based on the way the epidemic was going, and nothing was left to chance. And many people here were part of that. So I thank all the organizers, and I thank all the participants for coming again to another conference of GET Africa, and look forward to continued deliberations even after this conference. Thank you.
And those websites are at the bottom.
Please put your hands together once again.
Patients or patients under investigation should be taken directly, the sample should be taken directly to a biosafety level 2 laboratory and not stored or opened at workstations. That should be basic knowledge there. And they should be managed only in BSL2 or higher laboratories. And this includes, as noted by the previous speaker, the various types of samples that are collected, the nasopharyngeal swabs, saliva, urine, blood, feces, and tissue. Again, biosafety level 2 cabinet, PPE such as a surgical face mask or face shield or both, and should be performed, biosafety risk assessments should be performed to determine if any precautions are warranted based on situational needs. And that goes for a lot of biological samples that are collected. Those kinds of biosafety precautions are, here in the US, are mostly published by the US CDC, but the University of California, San Francisco also had such guidance. So isolating the virus in cell culture and viral agents recovered from samples should only be conducted in BSL-3 or the higher level laboratories and biobanks. And then there's guidance regarding biospecimen handling for decontamination, waste management, and packing and shipping. And again, the Environmental Protection Agency publishes information about such decontamination procedures. Bleach solutions are used And then waste management also includes other biohazardous waste in the laboratory. There's no evidence to suggest that this laboratory waste needs any additional packaging or disinfection procedures. And then packing and shipping, UN 3373, biological substance category B. So in biobanks and laboratories, these kinds of packing and shipping regulations and guidance are from the International Air Transport Association. And usually any biobank or laboratory in the world would have access to that kind of training. And in biobanks in the US, it's routine to train personnel according to IATA dangerous good regulations and packing and shipping procedures. So storage, this is coming up more and more now. No additional storage requirements are recommended for specimens, but as we have often done or always done in biobanks, when we receive samples that may have come from infectious patients, donors, agents, and those are treated as if they're highly infectious, and then those procedures that I showed on the previous slides about BSL-2, hoods and so forth are followed. And then again, the case guidance comes from mostly from the US CDC. And you can store specimens at 2 to 8 degrees centigrade for 72 hours. And if a delay occurs in extraction of DNA, for example, then store them at minus 70 degrees, et cetera, or lower. So I added a little bullet here the other day because here in the U.S., there's been a lot in the news, and I'm sure there as well, about the vaccines that have been developed, and some of them require shipping and storage at minus 70 degrees. Others only at refrigerator temperatures. And there's been a lot of talk about the cold chain for packing and shipping vaccines to remote locations, and the fact that inability to store samples or vaccines at minus 70 degrees. So some way of packing and shipping those in dryer, where you, it's called liquid nitrogen dewar, who many of you are familiar with, where you pour liquid nitrogen into the container, it's absorbed into the wall, and you put samples in there, and they can be shipped and stored for weeks at a time at liquid nitrogen temperatures. So those are some of the considerations for vaccines that are being developed. And here in the US, they're going to start being distributed, we think, by the end of this year to the more high-risk populations, such as the frontline hospital workers, physicians. So the next part of my talk is going to be about papers we're publishing in the December issue of Biopreservation and Biobanking called International Perspectives into Biobanking During the COVID-19 Pandemic. So since about March, we've been collecting papers from about a dozen authors from around the world, and the cover shows a heat map from September, when this cover was designed, about the prevalence of the disease in various countries around the world. And again, the US, South America are hotspots, as well as Russia at the time, some parts of Africa, but not as much, India, and by later in the year, summer and fall, the disease in Southeast Asia and China, Korea had pretty much disappeared. And I do some lectures to a class in China periodically. I have not traveled there this year because of the pandemic, but now in classrooms around China, people may still wear a mask, but they're meeting in person, and businesses have generally reopened, etc. So this special issue of the Journal of Biopreservation and Biobanking has responses, papers from a number of different countries, 10 or 12 from Africa and Ghana and Egypt, but also the US, Brazil, Canada, China, France, Japan, India, Australia, and Indonesia. And some of the topics include special standards and guidelines for COVID-19 biobanking, approaches to data sharing, biosafety guidelines, and review of clinical aspects of COVID-19 and potential therapies. So I'm going to show some, just highlight a few papers from that special issue, which will be available in mid-December in print. But if you go to this website, the publisher, Marianne Liebert Incorporated, which is in New York City, has made all the COVID-19 papers from our journal, as well as all of the journals that they publish, freely available. So you can go to that website and you can see all of the COVID-19 papers from this journal, as well as others about various aspects of the pandemic. So one of the papers was called a expert speak. And so we ask biobankers from these countries, Indonesia, Ghana, China, Egypt, Canada, Brazil, and India, several questions about the pandemic's effects on their region, impact on current biobanking operations, engagement with current research on COVID-19, and whether biobanks were prepared for these changes, and how this experience has modified preparedness and risk management and plans and perceptions. And the responses were highly variable. And again, this is freely available on that website that I just mentioned. Were generally that, of course, not many biobanks were prepared to receive samples from an emerging infectious disease. Some were, but because of their experience, prior experience, but many of them were not. Some of them engaged in research programs, but most of them had to quickly adjust their biobanks to collecting, receiving such samples. And they generally did a good job of this, but again, it required shifting personnel from doing their normal jobs to handling these special samples. And also, as the numbers increased, it kind of became a problem in terms of space for some of the biobanks. This is the paper that Dr. Knight from Toronto wrote based on his webinar. So it has a lot of clinical information about the disease that I did not show, and also discusses the biobanking aspects, again, based on the ISPR webinar. He wrote about the epidemiology, virology, transmission, clinical features, and major therapeutic options. And the therapeutic options have become outdated over the past few months as more options have become available, and the treatment of the disease has become the better experience and are saving more patients, and the outcomes are better than they were a few months ago, generally. So in France, there is something called the European Virus Archive, and I was happy to get a paper from this group. I had no idea that they existed, but they sent a very nice paper about their worldwide partnerships and how they have distributed samples, collected samples from the Zika virus from a few years ago, and also from the coronavirus and COVID. And so this is the EVA, as it's called, is a global science community with partners around the world, and how this paper explains how they've reorganized their activity towards diagnosing, understanding, and fighting this new pathogen, the European Virus Archive. And then a group from ISPR discussed the best practices and the new ISO 20387 biobanking standard. And they asked for ISPER regional ambassadors they've called from the Indo-Pacific Rim, from Australia, India, Indonesia, and Japan, and the director at large of the region to summarize their experiences in the region in response to the pandemic and how they used ISPER best practices and ISO standards to respond in their biobanks. And also, we got a nice paper from Iran about biosafety guidelines during the pandemic. And so they talked about the financial implications, the manufacture of vaccines and medicines, and the selection and evaluation and study of samples, and the biosafety angle of collecting and storing samples from the pandemic. And at the end, there's a large table that you can't read, but again, this is freely available on the website I mentioned, and includes a table of guideline references from the World Health Organization, the US CDC, an organization from the UK called gov.uk, and the Pan American Health Organization. So again, a nice paper about biosafety guidelines, some of which I mentioned in my slides from the doctor in Toronto. And finally, we had two papers. I'm showing one of them about data sharing for biobanks during the pandemic. And some of this is about international data sharing, having a laboratory information management system that can manage a data sharing network. And this makes a specific recommendation about data sharing. There's a separate paper that we received later with a broader review of several Linux options that proposes some global data sharing solutions, some of which may work, but it's, of course, as we know, it's very difficult to have various countries share data with one another. But again, there are some good recommendations that may become partially implemented in the future. So that's all I have to say. I hope that all made sense, a little bit about the handling of samples by biobanks and some of the international reactions. And I apologize that I can't hear very clearly any discussions from the podium. I only can hear questions and discussion through Zoom, where people are online. But anyway, if you have questions, I'll be happy to answer them by email or from the Zoom chat box. Thank you.
Thank you very much, Prof. We heard you loud and clear, and we are compiling questions. Just before your presentation, the director of the Lagos State Biobank did make a presentation, and there was there was a good flow, and there was consistency between what both you presented, areas and points of learning. So we did have them, and we will send the questions when we gather and put them all together. Thank you very much. Thank you very much.
Okay, and I'd be happy to receive a paper in my journal from the Lagos Biobank if you're interested.
Excellent. I think the organizers have your email address, and we'll send it to you. Thank you very much, sir.
Okay, thank you.
Another round of applause for Prof. Now, I know it's getting near lunchtime, but we have two quick presentations. They're going to take 15 minutes each. First person is Catherine Badesky and Dr. Wilmot James. They're presenting on nuclear threats initiative, and it's a team effort. Can we have both of them online, please? Are they ready? Excellent.
All right, well, wonderful. Thank you so very much for having us today. My name is Catherine Badesky. I'm with the Nuclear Threat Initiative, and we're a nuclear and biological security organization based in Washington, D.C. And I'm joined today by Professor Wilmot James.
So very good morning to you from New York. So I'm Wilmot James, and I am at Columbia University at the Center for Pandemic Research, and I serve as a senior consultant to the Nuclear Threat Initiative in Washington, D.C. And so I'm very pleased to share this presentation with Catherine Budesky with you this morning. So, so by way of introduction, if we could then have the second slide. This is a publication that appeared in Health Security, the magazine, the journal Health Security. And what it does, it outlines a global biosecurity dialogue as a model for advancing the global health security agenda. And if I can ask Catherine to speak to it.
Yeah, of course. Thank you, Wilmot. Just by a little bit of background, so security leaders often de-emphasize accidental and deliberate biological threats relative to other challenges in peace and security. And given emerging biological risks, including those associated with rapid technological advances and terrorist and state interests in weapons of mass destruction, biosecurity deserves stronger emphasis in health and security fora. So NTI launched the Global Biosecurity Dialogue to align national and regional donor initiatives towards a common set of measurable targets. The GBD was launched by NTI with support from Global Affairs Canada's Weapon Threat Reduction Program and the Open Philanthropy Project, in coordination with the government of the Netherlands as the 2018-2019 chair of the Global Health Security Agenda Action Package Prevent 3 on biosecurity and biosafety. And the Global Biosecurity Dialogue really provides a multi-sectorial forum for sharing models and enabling new actions to achieve biosecurity-related targets and promoting biosecurity as an integral component of health security. So this paper really dives into how that's been done, the history of the Global Biosecurity Dialogue, and specifically how it's contributed to new national and continent-wide actions, including the African Union and Africa Centers for Disease Control and Prevention's regional initiative to strengthen biosecurity and biosafety in Africa, which we will discuss in more detail later in our presentation.
So thank you, Catherine. So, colleagues, this is a heat map of biosecurity and biosafety. And what it wants to illustrate is how under-prioritized it is as an issue in the world today. So by way of background to say that, as you know, the joint external evaluations that were done over the last 4 to 5 years had questions in the technical areas that dealt with biosafety and biosecurity. And as you know, biosafety is essentially to protect individuals from exposure to dangerous pathogens, and biosecurity is to develop security systems around the pathogens themselves, so that they don't get into, so that there's no accidental or deliberate use of and leakage of pathogens. So what the Joint External Evaluation System did in terms of developing assessments is essentially rely on countries to request those evaluations. So this is voluntary. So there was a voluntary exercise, which means that lots of countries were not assessed. So the Global Health Security Index, in fact, which was released in October of 2019, was an effort to develop assessments for all the countries in the world, so all 195. And this is the result. So it's essentially 2019 data. So it's quite recent, and it covers every country in the world, and it's divided into 3 bands, as you can see. So the rest So in red, countries that are least prepared. In orange, as the intermediate level of preparedness, and yellow, most prepared. So you can see most of the world, in fact, is red, and certainly the entire continent of Africa is red, but together with significant parts of the world elsewhere. So the measures essentially here refer to biosecurity, to biosafety, but also to what's known as dual-use research and a culture of responsible science, both in labs, in the variety of sectors that we have, where labs operate. So this is the challenge that we face. You can see it's a global challenge, and the projects that we've undertaken is to try and address those. Next to you, Catherine.
Wonderful. So looking to this slide, how does the global biosecurity dialogue accelerate new collective and tracked actions? So first, biosecurity and biosafety are only effective when implemented and coordinated across sectors, such as those that are listed on the slide, so that we are all speaking the same language and working towards common goals. The GBD brings together these actors to discuss shared threats. The dialogue also encourages progress according to common milestones, such as those published by the World Health Organization. And the dialogue also really focuses on leveraging the expertise and experience from participants to identify barriers that prevent global progress towards biosecurity and biosafety targets, and challenges them to come up with new solutions to overcome these barriers along 3 work streams: policy frameworks, capability development, and emerging biological risks. And I'll give a bit more background on those in a second. And then finally, the dialogue tracks the ideas and commitments that come out of our meetings to hold participants accountable in alignment with existing international initiatives like the Global Health Security Agenda and the Global Partnership Against the Spread of Weapons and Materials of Mass Destruction. And again, we do this by focusing specifically on 3 work streams that were determined during our launch with all of our partners in 2018 in London. And again, they are policy frameworks, capability development, and emerging biological risks. So the biosecurity policy frameworks workstream really seeks to identify urgent actions that enable the implementation of comprehensive national biosecurity policy frameworks as a part of a whole of government biosecurity and biosafety system. The biosecurity capability development workstream seeks to identify urgent actions that can be taken to build sustainable and multi-sectorial national biosecurity and biosafety systems, including by improving access to regional and international networks of biosecurity experts to collectively enhance assessments, prioritize and track benchmarks in the national action plans for health security, and facilitate improved political will and resource mobilization. And lastly, the emerging biological risks workstream promotes actions to reduce emerging, future, or unanticipated biological risks associated with advances in technology, improve shared risk perception around countries and regions, incorporate emerging risks into existing tools and plans, and pursue international mechanisms to mitigate identified risks. At the Nuclear Threat Initiative, we like to think that we are always working towards systemic change in the field, so improving biosecurity and biosafety globally. So here you can see our model for how we would track this. So we launched the Global Biosecurity Dialogue to hopefully spur commitments to advance regional biosecurity models. Again, we're going to talk about the Africa CDC initiative to strengthen biosecurity and biosafety in a minute. So that was with NTI through our Global Biosecurity Dialogue with many partners. And now there's a biosecurity coordinator currently at the Africa CDC who we work very closely with, which is very exciting to see a permanent position there. Step 3, always working towards common metrics. So helping countries, working with countries to work towards set biosecurity benchmarks through their national action plans for health security. And step 4, hopefully at some point achieving systemic change. So seeing improvements in biosecurity scores in the GHS index, as Wilmot discussed earlier, and the joint external evaluation and then hopefully seeing this initiative potentially replicated as a regional model. So showing the leadership that Africa CDC has really taken on biosecurity and biosafety, and potentially having that model replicated in other regions.
So the initiative was launched on May the 8th, 2019 in Addis Ababa at the African Union. And the initiative was called, as you can see, an effort to strengthen biosafety and biosecurity on the African continent, which, as you know, and I come from South Africa, Cape Town, is a vast continent of 55 countries. And so, so we were delighted, in fact, to be able to launch this initiative at the Global Biosecurity Dialogue that was held in Addis with all of our partners. You may be able to recognize some of the faces of the people, but to say that this was an effort that was very closely linked in with the strategy that was being developed at the Africa Center for Disease Control, led by Dr. John Kengasong. And as Catherine mentioned, Dr. Tok Mo Maruta is now the Biosafety and Biosecurity Officer, covering the entire continent and working through the regional collaborating centers of the Africa Center for Disease Control. The Africa CDC, you know the Africa CDC. It is the youngest and effort on the part of the African Union to upscale preparedness, response, and detection on the African continent. And so we are just absolutely delighted to work with the Africa CDC as a partner. It's a very, very, very good organization, as you know, and has been doing extraordinary work during the COVID-19 pandemic outbreak on the continent. So to say that since we are looking at the Africa CDC as an organization that's built on an architecture of 5 RCCs, we have been holding our workshops with those RCCs as an outcome of this initiative. And we've covered a number of workshops in the meantime prior to the current one that we are busy with in West Africa, starting with the first one in Southern Africa.
Wonderful. Thank you, Wilmot.
Yeah.
Okay, so Wilmot mentioned that there have been technical workshops that have been hosted by each of the regional collaborating centers. We've now hosted them, each of the regional collaborating centers has hosted them within the Eastern, currently Western, starting with the Southern, and also in Central Africa. 2 of these workshops were in person before the COVID-19 pandemic. Those were in Southern and Central Africa. And while all of the technical workshops have had 2 of the same objectives, we've added a third due to the pandemic. So I'll just read these. So they are to develop priority actions required to fill biosecurity and biosafety gaps, leveraging national and regional resources and informed by existing health security related assessments, strategic implementation plans to promote measurable progress towards the achievement of the WHO Joint External Evaluations, biosafety and biosecurity targets, and to meet obligations under the Biological Weapons Convention and the United Nations Security Council 1540. And the other is to conduct technical working group meetings to provide an overview of risk assessment and risk-based decision-making guides to guide the development of a standardized process to support the establishment of an African Union biorisk management legislative framework and the drafting of a consensus list of high consequence agents and toxins of concern for African Union member states. But as I mentioned, amid the COVID-19 pandemic, the initiative to strengthen biosecurity and biosafety leveraged its diverse community of cross-sectorial biosecurity and biosafety experts to provide much needed biosecurity and biosafety trainings and to raise awareness on programs specific to COVID-19. So in the Eastern and Western Africa regional technical webinars, there was a focus on both the enduring themes of the initiative intended to fill biosecurity and biosafety gaps, as well as discussion on safe and secure sample transportation, inventory, and storage of SARS-CoV-2 infected materials to prevent accidental or deliberate release of this dangerous agent. So I'll now turn it back over to Wilmot to discuss our first workshop in Southern Africa.
Thank you, Catherine. So the first workshop was held in Johannesburg at the University of the Witwatersrand in June of 2019. We assembled representation from all the member states of the Southern Africa Collaborating Center of the Africa CDC. We went through the first effort at a training exercise in the technical areas of biosecurity with a focus on laboratory security and pathogen protection. The key focus of the workshops was to essentially two things, is to work towards developing model legislation that can be lodged at the Africa CDC headquarters in Addis, and then serve as a resource for both the regional collaborating centers and a resource for member states to develop legislation in the area of biosecurity in the individual countries. There's obviously great variation across the continent. Some countries require new legislation, some countries require amendments to legislation, and others require new sets of regulations. So that was the one focus. The other focus was to develop lists of high consequence pathogens and toxins. And so this is the first inaugural training workshop, and it was done in collaboration with the CDC, with Foreign Affairs Canada, and a range of other partners that includes the WHO and other agencies, but principally as a workshop of the Africa CDC, looking at member states in the Southern African Regional Collaborating Center. The second workshop was held in Gabon, and Catherine, you want to speak to that?
Sure, thank you, Wilmot. So from October 1st to the 3rd, 2019, Africa CDC hosted the second of the Regional Collaborating Center technical workshops in Libreville, Gabon. So we had participation there from the 9 member states that make up the Central African RCC across human health, animal health, and defense and security sectors. And the 3 outcomes of those of that meeting were that Africa's Center for Disease Control, Central Africa RCC, agreed to set realistic biosecurity and biosafety capacity building goals for the region and track progress. They agreed to request the member states nominate a multi-sectoral body for reporting on successes and challenges in achieving these goals, and apply regional solutions to common challenges and facilitate the sharing of lessons learned amongst member states. The Central Africa RCC also pledged to fill recognized biosecurity training gaps by coordinating a regional effort through partnerships with Africa CDC's Institute for Workforce Development, Columbia University, and the Association of Public Health Laboratories to adapt existing biosecurity and biosafety training curricula to the Central African member states. And lastly, for representatives from the Central African member states who participated in the meeting, agreed to nominate representatives of the region to participate in the African Union Biorisk Management Legislative Framework Development Process, and sensitize national and regional leadership and technical experts to the framework to enable timely build-in, hopefully once it's endorsed by the African Union. And as Wilmot said, these workshops are a collaboration of the African Union, Africa CDC, the United States Center for Disease Control and Prevention, and the U.S. Defense Threat Reduction Agency. All right. And then do you want to talk about the Eastern Africa RCC technical workshop?
So we obviously plan to do this in person, but with COVID-19, it was an effort to offer this workshop virtually, and so it was a real experiment for us to do this. We were delighted to work with the East Africa a regional collaborating center of the Africa CDC based in Kenya, and then worked with colleagues there to put this workshop on during this year, July, June of 2020. So you can see in the picture there, Lennox Kensington from Makerere University in Uganda did the presentation among many others. And in this case, this particular focus had to do with the taking of direct action that would look at reducing deliberate and accidental risks during COVID-19 in particular. So that is our current environment, and there are biosecurity aspects to how it is we deal with samples, how samples are stored, how samples are transported. So the whole question of developing biobanks and security systems around that. The question of laboratory security came into focus when it comes to working with samples and exposure systems and so on. So this was clearly an important time for us to make sure that we upscale biosecurity dimensions to the COVID-19 outbreak. And so what we did was focus in particular on our current pandemic threat and make sure that we use the opportunity to upscale biosecurity systems, certainly on the continent as a whole, but with a focus in this case on East Africa. So, so it was quite successful. It's the first time we did a virtual one, as this conference here is being held. But as you can imagine, trying to develop a training program virtually in a technical area can be quite a challenge, and we were very pleased with the outcome from our East African workshop.
Absolutely. So currently, we're very excited to be hosting with Africa CDC and the West African Regional Collaborating Center, as well as WAHO, the West Africa Regional Technical Workshop. So while this workshop is actually still ongoing, over the next few weeks, we're going to continue to have track discussions where we're specifically talking about how we can spur collective action under the two main objectives of Africa CDC's initiative to strengthen biosecurity and biosafety, specifically focused on the development of a legislative framework, as has been mentioned, and on capability development. So we're excited to continue to have these dialogues over the next few weeks, and are very thankful to our regional partners in West Africa. And so really to conclude, our next steps are hopefully, with the leadership of Africa CDC and the Northern Africa Regional Collaborating Center, we will hopefully be able to host with a host of our other partners a Northern Africa Regional Collaborating Center technical workshop in early 2021. And in order to track the progress that has been made under each of these regional collaborating centers on the issues of biosecurity and biosafety, Africa CDC has put together technical working groups led, again, by Africa CDC in each of the regional collaborating centers. And we've had the first meeting of the Southern Africa Technical Working Group, which is fantastic. So that will really follow up on all the work that has been done to put together project proposals to move forward to advance biosecurity and biosafety in each of the regions. And then in early 2021, we're also hoping to host our annual Global Biosecurity Dialogue with a focus on Southeast Asia, actually. So those are all upcoming. At the upcoming GBD, absolutely talking about the incredible progress and leadership of Africa CDC and the action that has come truly from the initiative to strengthen biosecurity and biosafety on the continent. So these are our upcoming, or hopefully upcoming events. And we really look forward to continuing to work with Africa CDC on the initiative to strengthen biosecurity and biosafety.
So with thanks for the invitation, the opportunity to address the meeting, and to say that our best wishes for what it is you're doing, and to salute your leadership in this area of scaling biosecurity and biosafety in the African continent.
Yes, thank you so much to the organizers today. We very much appreciate being able to share with you all of this work.
Excellent. Thank you very much. Hello. Thank you very much. That was both Catherine and Dr. Wilmot James. We heard you loud and clear, and I particularly took note of the next steps, particularly on the common events of 2021, and we will also send questions or whatever queries we have. The next speaker, and the last before lunch, is Dr. Vlodek Mandeki, President Pharmasac, and he's going to talk about innovation technologies for biobanking and fighting infectious diseases. Is Dr. Vladek there? Over to you, sir.
Yes, I would like to make sure that you see my screen, the first slide. Yes, okay. Thank you. Thank you for the invitation. We will change focus a bit now in my presentation and talk about interesting biomedical technology and its potential impact in Africa and elsewhere. But first, a few words of introduction. I am Włodek Mendeki and represent Pharmacic. Pharmacic is a company located on the east coast of the United States in New Jersey, between New York City and Philadelphia. The company was founded 20 years ago to be a champion of innovative biomedical technologies and more. I am the founder and currently president and director of scientific research at the company. In my spare time, which I do not have really, I am adjunct professor at Rutgers University nearby. Needless to say, technology is key in biomedicine in any country, also in Africa. Why is that? Combating disease, especially fast-changing infectious disease, requires quick response, effective treatments, and diligence when dealing with patients and also patient samples. And this is only possible with new technology when the doctors and nurses can focus on patients because new technology does the rest. Pharmacic, my company, is active in many areas. Here I will present our contribution to two areas. One involves equipment for biobanking and histopathology, and the other is immunoassay technology, where I will mention our work on dengue immunoassay. It turns out that at Pharmacic, one technology is common for many types of our developments, especially two developments that I mentioned. This technology is the P-chip technology. Pharmacic developed an ultra-small electronic chip with memory that is the foundation for both bioassays and tracking and authentication in biobanking. So let's look at that technology. What is the P-chip? Well, this is the tag which in biobanking, for instance, we attach to test tubes and other containers in histopathology to glass slides. That way, after attaching, we give an ID to these objects and can monitor and track them. The main purpose of the P-chip is to transmit a serial number encoded in P-chip's memory to the a reader of PCHIP IDs. This will happen if the PCHIP is activated by light from a laser. So in this picture, we see a PCHIP on the lower left where we have a schematic representation of what's on the PCHIP. First of all, there is a photocell. The purpose of the photocell is to provide electrical energy to the PCHIP by converting light. Secondly, memory. Third, logic, kind of the brain of the PCHIP, and also the antenna to transmit the signal to the outside by radio frequency. The size the size of the PCHIP is 500 microns on the side, and the thickness is 100 microns. It's very small. If you are not used to it, it's hard to see that PCHIP. The key here is the 64-bit architecture, translating right now to over 10 to the 9th different IDs. We never make two PCHIPs with the same ID. Also, the important characteristic of the PCHIP is that it is virtually impossible to copy its ID, since making of the PCHIP requires a silicon foundry, a very expensive type of factory, and also proprietary coding. PCHIPs are made on silicon wafers, top left, where we see an 8-inch wafer containing sections. Each section has 1,000 PCHIPs. Top right, this is the real image of the PCHIP. Let's compare the PCHIP with other identification methods in biomedical research. Well, the most well-known is the barcode, introduced in 1974. There is 2D barcode in 1988, and more recently a QR code. In terms of identification, there is one significant issue with barcodes. They are not secure, meaning they can be printed or deposited on the object of interest at will. Well, in this same field, we have RFID chips and tags. The problem with them is that they are, relatively speaking, huge, ranging in size from few millimeters to inches and more than that. Well, therefore, our PCHIP, pharmacy PCHIP, is attractive in terms of tagging, authentication in biomedical research. Well, if we have a PCHIP, we have to have a reading device to read IDs of the PCHIP, and that's a picture and a high-level schematic of the reader. It is a wand type of device, length about 12 centimeters, and the key element of the reader is the laser. So that laser shines light on the PCHIP, radio frequency signal comes back, and electronics inside the wand processes the signal and sends it to the laptop or a tablet. Well, the PCHIP works so well for tagging and also in bioassays because it tolerates adverse conditions quite well. It is stable to temperature changes. We can go from minus 200 degrees Celsius, that's nitrogen storage in biorepositories, to 500 degrees Celsius. Amazingly, at minus 200 degrees Celsius, the PCHIP ID will read fine. Well, PCHIP is stable to microwave radiation, high G-force, also solvents and reagents like those typically used for staining in histopathology. The P-CHIP ID can be read through animal tissue. That's why the P-CHIP is perhaps the best tag for tagging laboratory mice and widely used. I'm going to focus on P-CHIPs in biorepositories. We developed several types of readers other than what I showed you earlier, the wand. Here on the right, top right, we have a single vial reader. In a device like this, we would place the tube in the opening on the top, and with no delay, the ID will be presented on your computer. If we want to read glass slides in histopathology labs or tissue cassettes, we would slide them through the opening in another type of reader. And finally, we have a reader for racks of tubes. You may ask, how do we tag test tubes, vials with P-CHIPs? We have at least a couple of methods to do so. One relies on placing a P-CHIP in a cavity in a specially designed tube, covering this with a lid and a heat staking, and that way we get tubes which then appear like this. The P-CHIP is the thing on the center bottom of the tube, and a rack of P-CHIP tagged test tubes. Another method to place P-CHIPs in test tubes is to heat staking, a thermal embedding method. I want to do a couple of movie clips. This is the first one. We call it the array reader for racks of test tubes. I'm gonna play the movie clip, a couple of seconds, and you'll see how we read P-CHIP IDs. And that was it. Very easy indeed. Okay. Well, it turns out, amazingly enough, that P-CHIPs do not have to be embedded in plastic of the test tube to provide tagging for patient samples. We have a collaboration with a lab directed by Dr. William Grover from the University of California, Riverside. And they are working with us to show that the tagging method in which the P-CHIP is simply placed inside the test tube is adequate for sample tracking. The advantage is that when we want to move the sample, the P-CHIP will travel with the sample. So, so there is quite a bit of work going on in this field. We have a grant from the Bill and Melinda Gates Foundation, phase 1. We applied for phase 2 of that grant, and we'll see how it goes. But I want to mention one thing. We have a very significant collaboration on this project with the institution that you will know very well. The name is ILEAD, which stands for African Laboratory. That's an African Laboratory Initiative named Innovation in Laboratory Engineered Accelerated Diagnostics. They have 3 centers of excellence in South Africa, Mozambique, and Senegal. Well, a frequent problem in the histopathology labs. Many of you probably know how this type of an image where we have a drawer in a cabinet full of glass slides, microscopic glass slides stacked vertically. It is very difficult to find the slide in such a setting. So we have a solution for that. We have a solution in which we place the P-chip on a glass slide, and you wouldn't guess what the favorite position is. The favorite position for the P-chip is on the short edge of the microscope glass slide as shown in the top panel here. So these are P-chips. We can place them into a cavity in that short edge like this. So what it allows us to do is to have a situation where in a drawer with vertically aligned glass slides, the P-chips are exposed and their IDs can be read with a slightly modified version of our wand. I will play this a bit. You'll see how the P-chip IDs are read, like 70 in this case, at a time. And if you listen, you will recognize a different sounding beep that indicates that this P-chip was found by the reader. That sound corresponds to the slide which we are looking for in this particular experiment. That was the sound. Okay. Potential benefits in biobanking are large. Improved efficiency, increased accuracy, safety through improved safety through a reduction of medical errors, ease of storage and access, and the cost savings. I'm going to switch gear and talk about bioassays that will involve our new instrument that's being developed called Cyclone, and I will speak a little bit about dengue immunoassay. Well, again, this type of picture is familiar to you. The picture describes the frequency of dengue seropositivity in Africa. The message from this picture is that it is expected by experts that dengue risk across Africa will grow. And that's why we consider it worthwhile to develop systems and assays that can be used to combat dengue and many other diseases. So first of all, let's imagine an immunoassay. This is an example of an immunoassay detecting an antigen. So to do the assay, we derivatize P-chips with antibodies, then expose the P-chip to the sample. Antigen from the sample binds to the antibody, and then we follow up with the secondary antibody and place a fluorescent moiety on the antibody in some way, like with the secondary antibody. So that's a typical configuration of the assay. On the DNA side, we would take a P-chip, synthesize an oligo, and then derivatize the sample, DNA from the sample, in such a way that we have fluorescent tag on the DNA. And therefore, when the assay is being conducted, we get fluorescence on the P-chip. The biggest advantage, biggest benefit from the P-chip is that we can pursue multiplex assay in one test tubes. So it's somewhat reminiscent of Luminex-based assay, but we have several advantages. Then how are the P-chips read? So these are fluorescent P-chips, and the RF and the ID of the P-chip indicates what type of target we are trying to detect. P-chips are passed through a channel in front of the light beam, and what the light beam does is that it induces fluorescence that tells us how much target there is in the sample, and second of all, activates the electronics of the P-chip, which sends an ID, and that way we get the information about what target P-chip was exposed to. So this works quite well. We have an instrument devoted to this assay called Simiplex, but I'm not going to talk about this much because I want to focus attention on another type of instrument. If you think that passing chips in a channel is a reasonable way to go, you will agree with me that that passing the P-chip in front of the light beam in a rotational motion is also adequate. Well, we can place the P-chips in a test tube and then rotate the test tube in front of the laser beam, and that way acquire data. This is being done, the assay is done in capillaries like this. They are capillaries, test tubes used for real-time PCR, very narrow. You see P-chips on the tip of the capillary. So when the P-chips in the capillary are rotated in a special equipment, we can expose the P-chip to the laser beam and then get fluorescence and the ID of the P-chip. The instrument is being designed. We have a prototype, an early prototype. This picture shows a CAD model on the right and rendering of the instrument. And I want to focus your attention on the extremely small size of the instrument. We compare it to a Rubik cube, maybe 5 inches, slightly larger, 5 inches by 5 inches by 5 inches, and another element that is needed is either a smartphone or a tablet. This can be connected in principle to a battery in a car, and under difficult conditions provide equipment for tests. That's under development. We got funding for this project from Center of Disease Control in the US. That's the primary government organization, the focus of which is protection from diseases. So I would like to summarize what I told you. I presented to you P-chip technology that gives rise to 2 major applications. One is improved identification of specimen in laboratory, and second of all, access to low-cost assays and instrumentation, with significant benefits in efficiency, accuracy, reduction of medical errors, storage, and access and cost savings. That's the presentation. I want to thank you for attention.
Ladies and gentlemen, please put your hands together once again for Professor Lodek Mandeki. Please put your hands together for him. I believe experts in the room here, just listening to him and seeing the videos of innovations, I'm saying to myself, really exciting times ahead for us. If you ask me, we've already made it very clear here. It's a new norm. We are going to be dealing with one sort of virus or the other. Preparedness remains, our task as it is, and seeing the fact that you have innovation that makes it safer, makes it faster, or rather than just one word, makes it more efficient, I think it's just beautiful to see. Honestly, I wish this was my own field, because I guess I'd be going over my head right now saying, did you see that? We can actually do this and do that with what's been made available. Interesting. Anyone with questions for Professor on his presentation? None? I always say when we don't have questions, it means everyone really understood it, or they're just in awe of what Professor has shared. I'm sure his email address will be shared as well. So in case you have direct questions you'd like to ask him, that is also possible. Thank you very much, Professor, for your time. Thank you for joining us, and have a wonderful day ahead. Ladies and gentlemen, lunch is served. And just as we've done in the past 2 days, you will be expected to eat behind the board. When we come back, we have a couple of abstract presentations, messages from our sponsors, and of course, the conference takeaway at the end of the day. And I'm sure many here would like to know where the location of the 7th conference will be, where the location, where the 7th conference will be taking place in 2021. Well, all that and more we have after the break. So let's get up and go eat. We have just 1 hour to enjoy lunch. It's really looking delicious out there. So please go out and have first bite. Thank you very much. Okay, we're not really waiting for anyone to go first. Please just go out there and eat. Let's get up and do it. We have just 1 hour. And after 1 hour, we're going to have to hurry everyone back in here so we can round up. So please, lunch